things to do this weekend. Take it little by little. So the first question about main sequence stars, the best answer there for number 1 is A, that they convert hydrogen into helium. Question 2 was a question about pulsars. They are B, a rapidly rotating neutron star. Question 3, which of these processes involved in sunspot cycle? We actually saw that on the video too, that the best answer there is E, kind of the winding up of the magnetic field lines. That's, like I said, it's almost like playing Twister. Question 4, what kind of star is most likely to become that type of supernova, white dwarf supernova? Well, that would be a companion sort of situation. And actually, this is related to one of your short answer questions about the sun. Will the sun ever be a white dwarf supernova? And the answer is no, hands down. It needs a companion, so B is the best answer there. Question 6, the faintest star under dark skies that you can see with your naked eye is a magnitude +6, D. Question 6, stars begin their lives with similar composition, but E, it's the mass that they're formed with that makes the difference, the most difference. Question 7. Now, question 7, I think, was probably among the hard questions, I think. It was actually that kind of thermostat sort of thing that goes on in all stars, including our sun. But the best answer there is A for 7. The rate of fusion, if the rate at which fusion occurs would increase, okay? Oh, what would happen if the temperature rose? Okay, and the best answer is A, that the fusion rate would increase and then it would expand, and then actually that would make it cool. So A is the best answer, kind of describing 1/2 of that sort of thermostat cycle. B, what eventually halts the collapse of interstellar gas cloud before the star actually becomes a full-fledged star? And the best answer there is A, it begins nuclear fusion in its core. Question 9, list the 7 spectral types in order of hottest to coolest, and the best answer there is A. Oh, be a fine guy or girl, kiss me. Question 10, the core of the sun is, the best answer there is B, much hotter and denser than its surface. That's why we get nuclear fusion going on in the cores of stars. Question 11, how does a black hole form from a massive star? The best answer there is C, during the supernova. Basically, the gravity of the object overcomes neutron degeneracy and it collapses in on of itself to create a black hole. Question 12, which of the following comparisons between low and high mass star main sequence stars is true? So A is true, that low mass stars are cooler and less luminous than high mass stars. Actually, this is one of the ways you could have answered one of your short answer questions at the end too. Question 13, the light radiated from the surface of the sun takes about 8 minutes to reach the Earth. But we talked about kind of the long journey it takes from the core outward, especially through the radiative zone. So E is the best answer there. It takes several 100,000 years to actually navigate from the core outward. Question 14, what is the fate of an isolated brown dwarf? And I don't know if I emphasized this, but a brown dwarf, of course, is a failed star. And basically, it's just going to cool off. And it could actually be something we call dark matter. But it will remain a brown dwarf forever is probably the best answer there. Question 15, helium fusion results in the production of B, carbon. Question 16, if you were to visit our solar system 6 billion years from now, now that's where you need to remember that our sun has about 10 billion, it had about 10 billion years worth of main sequence life in it. It's about halfway through, so actually in another 5 billion years, it's going to leave the main sequence, become a red giant. So that's actually, so then at 5 billion years, so another billion years past that, actually it's going to leave its red giant stage and become a white dwarf. So B is the best answer there. So that actually probably was another one that I'm like, oh, that's kind of tricky. Question 10, if you have a main sequence star that is about 10 solar masses times the mass of our sun, it's actually going to go supernova, and it will end up as a neutron star, the remnant will. 10 is the threshold for I believe neutron star and then black hole. Direct. Come back. All right. 18. What happens, you guys have it in front of you, what happens when a star like the sun exhausts its hydrogen supply in its center? You're the reason I lost my place, so I'm not very impressed. I am not humored. This is working, and that's working. Computer on. Like Scotty on the, yeah. You were working. Next one. Direct. All right.
We got there.
All right then. Question 18, what happens when a sun like ours leaves the main sequence? It's actually, the best answer there is E. Its core is going to contract and its outer layers are going to expand. And then on the HR diagram, it's going to kind of move up, so it's more luminous, but it's going to be red, which means it's cooler. So E is the best answer. Question 19, suppose a white dwarf gets dumped on from its companion. What happens if that white dwarf reaches 1.4 solar masses? That's the Chandrasekhar limit. The best answer there is C, that it's in line to basically blow up, supernova event, because it's going to create, have nuclear fusion going on in its core. So C is the best answer. Question 20, on an HR diagram, where are you going to find those cool and dim stars? So that would be the lower right. So B is the best answer for 20. Question 21, what happens to the core of a star after it ejects its planetary nebula? It becomes D, a retired star, a white dwarf. This again was one of your short answer questions. Question 22, at the center of the sun, we have our nuclear fusion going on, and that is converting hydrogen. The best answer there is B, into helium, and you also get gamma rays. That's the energy in neutrinos. Question 23, what causes the pulse in a pulsar? The best answer there is B, that the neutron star is spinning, and beams of radiation actually are sweeping through space, and we can observe them as a pulse. That actually is the lighthouse model. Question 24, which of the following statements about apparent and absolute magnitude are true? Actually, all of them are true. It's true that absolute magnitude is associated with luminosity. It's also true that that absolute magnitude and apparent is what the apparent magnitude would be if it were at a distance of 10 parsecs. It's also true that if you have an apparent magnitude of +1, it's brighter than +2. And it's also true that the system we have was come up with a long time ago. Question 25, on an HR diagram, where do you find the white dwarfs? That would be the lower left, so D is the best answer for 25. 26, compared to the star it came from, the red giant is actually cooler. It's down to the right, and it's higher, brighter. So D is the best answer there. Question 27, we talked about binary stars and 3 different types of binary stars. And this is describing D, a visual binary, where you see a pair of stars that appear to change position and you actually see them, okay, and they're orbiting each other. That actually is a visual binary. D is the best answer. Question 28, which of these are true? Which of this following statements about nova is not true? And so again, this goes back to the short answer question. It's not true that our sun is going to undergo a nova event. The other actually are true. Question 29, so B is the best answer for 28. 29, by what process does our sun generate energy? E, nuclear fusion. That was a quiz question. Question 30, on the HR diagram, just focusing on the main sequence stars, where do you find those that have the greatest mass? That would be the upper left. C, question 31, after a supernova event, your options of kind of that little core thing that's left behind is E, either a neutron star or a black hole. Question 32, what's going to be the ultimate fate of a white dwarf? And it's similar to a brown dwarf. E, it's just going to cool down and become a cold black dwarf. Question 33, which of the following best describes the axes of an HR diagram? We have surface temperature on the horizontal axis and luminosity on the vertical axis, B. Question 43, the age of a star cluster can be determined by the turnoff point, C. Question 35, which of these describes the stages for a low mass star? The best answer there is E, a protostar, main sequence, red giant, and then white dwarf. Question 36, a star's luminosity is the C, total amount of energy it's beaming out each second, the wattage. Question 37, what is the upper limit to the mass of a white dwarf? That's the Chandrasekhar limit, 1.4 solar masses, E. Question 38, which of these is not true about black holes? It's not true, the one about our sun. It's not true that E, if the sun was to magically be replaced by a black hole, it's not true that the Earth would soon be sucked into the black hole. Gravity would kind of do its thing like it's doing it unless you were close to the event horizon. Then on to vocabulary. These were each worth 2 points apiece, so in some cases you got 1 out of 2 points. I was after neutrinos as that kind of elusive particle that the sun creates during nuclear fusion. Question 40, I was after globular clusters as that ball of stars, and they're relatively old stars. Question 41, I was after molecular cloud or giant molecular cloud. If you put nebula, I think I gave you 1 out of 2 points, as basically where a bunch of stars can be born all at once, stellar nursery. Question 42, another question about binary stars. So this was the eclipsing binary that's being described here. They are detected by watching light from a pair of stars change as one star periodically passes or eclipses the other one. Question 43, I was after luminosity is the amount of power an object radiates per second, given in units of watts. Question 44, if you put convective zone, I think I gave you 1 out of 2, but actually it's the radiative zone that is closest to the core, and that's the one where it's the random walk out the radiative or radiation zone. Question 45, I was after brown dwarf as a failed star. Question 46, I was after event horizon as basically that region around a black hole that don't go past, because nothing even traveling the speed of light can escape once you're in the inside of event horizon. I was after gravitational redshift as the influence that gravity can affect on radiation. Basically, the light has to kind of find its way out of a gravity hole, gravity well, excuse me. Question 48, I didn't talk a lot about it, but we call it time dilation, the whole slowing down of time as you get close to a black hole. And yeah, and I can see that, actually I didn't even, this is like in throwback when I used to kind of talk more about approaching the speed of light. You also get time dilation in addition to going near a black hole. That one won't make it to the final. Question, now short answers. What do we mean by white dwarf? Pretty good here. I took an assortment of answers. Question 50, I was after I said gravitational equilibrium, but you guys kind of played along with me, and basically that's the sun is neither expanding nor is it shrinking because of the amount of gravity is counterbalanced by its outgoing energy from its core. Question 51, I wanted you to tell me how we can use an HR diagram to see a star as it ages. And again, you could give a couple of different answers here. Some students just kind of went and said main sequence, giants, white dwarf, and to me that was okay. But basically an HR diagram shows us a star changing its temperature and luminosity as it ages. Question 52, I took kind of an assortment of answers, but here was kind of what I was after when you compare high mass and low mass stars just in general. The high mass stars live short lives, they're bright and they're blue colored. The low mass stars live long lives, they're relatively dim and they kind of have a reddish color. Question 53, this one might make it to the final. I don't know if everybody, we're going to be on the same page here. Our sun is not going to go nova, nor will it go a supernova, because it will be a white dwarf, but it doesn't have a companion. Okay, to me that was the best answer for 53. 54, to get the full 3 points, you had to not only kind of explain what an accretion disk is, but you had to tell me how does that relate to the nova getting a second life. So that's kind of what I was after for somewhere in there. So these are, I think they're already under doc sharing. This document is under doc sharing, the answer key. So, you know, getting ready for your comprehensive final in a few weeks. You might want to print those out or have yours. Now, if you weren't here to get your graded unit exams, I have those actually on file. I'll try to remember to bring them like our last date before finals, so I can hand it back if you're here. All right, so that is that.